Friends, transfer function is the Laplace transformation of output variable to the Laplace transformation of input variable with all initial conditions set to 0. That means that transfer function will not give the response due to initial conditions. Total response of any system can be classified as zero input and zero state response. Zero state response means this is due to applied input. Due to input of the system, this is due to input of the system, applied input rather. And this response is due to initial conditions. Due to initial conditions. That means transfer function will not give the response due to initial conditions, zero input. So due to initial conditions, therefore transfer function, the zero input response can't be obtained using the transfer function. Zero state response means initial conditions are zero. Therefore transfer function gives only a zero state response due to applied input. Hence the transfer function zero input response can't be obtained using the transfer function based approach. That is a drawback of the transfer function. Sensitivity of output with respect to feedback path parameter changes is asked. Given data is forward path transfer function is given, feedback path transfer function is given. Transfer function, we know that closed loop transfer function, let us call it as m, g divided by 1 plus gh. Sensitivity of output with respect to changes in h or sensitivity of m means this is transfer function, is one and the same with respect to h, because m is nothing but c by r. M changes, c changes, both are same. C is proportional to m here. C is proportional to m. Therefore m changes and c changes, both are same. Sensitivity of output with respect to changes in h or m with respect to h. Dou m by dou h by m, we get minus gh by 1 plus gh. By substituting, simple substitution it is, sensitivity of c to h is equal to minus 1 by s plus 1 g, this is 1 by s plus 1, divided by 1 plus gh into 1 by s plus 1, which gives minus 1 by s square plus 2s plus 2, we get it. S square plus 2s plus 2, we are going to get it. Here, minus implies that if h is increasing, m decreases or output c decreases, vice versa. If h is decreasing, output c increases. The variations are in the opposite direction. So therefore, this is the answer for this. The DC gain of the system is asked with R2 as input. With R2 as input and C is the output. That implies that R1 is equal to 0. We have to find the transfer function with respect to input R2. Therefore, C by R2 we have to calculate. C by R2, R1 is equal to 0. DC gain we have to estimate. We have to calculate the DC gain. DC gain means zero frequency gain. S is equal to j omega, omega is equal to 0. Or S is equal to 0, directly we can substitute. Always for the given block diagram, apply Mason's gain formula. Do not use the block diagram reduction. Here, it has one forward path and this has one loop. That loop is a negative negative feedback. Therefore, applying the Mason's gain formula, C by R2 is equal to M1 delta 1 by delta, only one forward path. Therefore, M1 delta 1 by delta. Here, delta is 1 minus sum of the loop gains. There is only one loop with a negative feedback. 1 by S plus 1 into 10 by S plus 2 is the loop gain. And the forward path R2 to C is 10 by S plus 2. Simplifying this, 10 into S plus 1 divided by S square, 3S plus 12, you get it. This is the gain C by R2. By setting R1 is equal to 0, implied that the R1 is equal to 0. DC gain means substitute S is equal to 0. 0 frequency gain. You get 10 by 12, which is 5 by 6 is the answer. DC gain due to input R2 is 5 by 6. That is the answer. Given data is Nyquist plot is given, we got to find the equivalent Bode plot of this system. It is a third order system because omega is equal to 0, initial angle is minus 90 degrees. So type 1 system. Final angle is equal to minus 270 degrees. That means it has 3 poles. Therefore, the corresponding transfer function is K by S into 1 plus ST1, 1 plus ST2. Minimum phase system it is. No poles and zeros right side. It has one pole at the origin, initial angle minus 90 degrees. Total number of poles are 3 poles. Final angle is omega tends to infinity is P minus Z into minus 90. Therefore, minus 270 degrees is the final angle. This is the transfer function. Bode plot for this is, it is type 1 minus 20 degrees initial slope, 20 dB per decade is the initial slope up to corner frequency omega 1. Omega 1 is 1 by T1. Omega 1 is 1 by T1. And at that, one more pole comes, then it becomes minus 40 dB per decade. That is up to omega 2. Omega 2 is 1 by T2. At omega 2, one more pole comes, minus 40 becomes minus 60 dB per decade. So using the options, one can say easily, because it is third order system, final slope should be minus 60 dB per decade, initial slope type 1 system minus 20 dB per decade. Therefore, option D matches. Where here omega 1 is equal to 1 by T1, omega T2 is equal to 1 by T2. Therefore, this is the given answer. Friends, root-lossy diagram is given here, and K is equal to 1, the transfer function is asked. The closed loop transfer function is asked for K is equal to 1. Here, from the given data, loop transfer function poles are at the origin, one pole is there, minus 2, one pole is there. Therefore, the loop transfer function, some people call this one as open loop transfer function, GSHS, is K divided by S into S plus 2. K divided by S into S plus 2. For K is equal to 1, closed loop transfer function is asked. Okay, the feedback is unity feedback. What is given here? Feedback, unity feedback control system it is given. Therefore, for K is equal to 1, k is equal to 1, closed loop transfer function is gs by 1 plus gs hs. That is 1 by k is equal to 1. K is equal to 1, if you substitute 1 by s into s plus 2 divided by 1 plus 1 by s into s plus 2, 1 by s square plus 2s plus 1. Friends, that is the closed loop transfer function. But to my knowledge, one must not use pen paper for this. Definitely value of k here is 1 because 1 into 1. Breakpoint is a midpoint. S is equal to minus 1 is a breakpoint. When you say S is equal to minus 1 breakpoint, at the breakpoint k is equal to 1 here because distance from poles product is 1 into 1 divided by no 0. Therefore, k is equal to 1 here. Hence, closed loop poles for k is equal to 1 is S is equal to minus 1, S is equal to minus 1, double pole. Therefore, transfer function is 1 by S plus 1 square. One cannot, one don't need a pen paper to solve this problem. Therefore, answer is directly you can read from that it is 1 by S plus 1 square is the answer, which is so simple like this. Given here is forward path transfer function, feedback path transfer function is given. The time constant of the system is asked. Do not forget, time constant is nothing but reciprocal of the pole. The closed loop transfer function is a by 1 plus st plus ab. You get g by 1 plus gh if you substitute. And the denominator equation is the characteristic equation. Roots are poles. Pole is s is equal to 1 plus AB divided by T, you get it, pole. And time constant is T by 1 plus AB. Therefore, reciprocal of the pole. If pole is minus 3, time constant is 1 by 3. Therefore, here pole is 1 plus AB by T, time constant is T by 1 plus AB. Number of left-hand roots of that polynomial is asked. That polynomial is this given polynomial. So, using the RH tabulation, it is possible to find the right-hand roots. Based upon that information, we find the roots on the imaginary axis and left-hand side as well. Therefore, we have done the tabulation, RH tabulation. After the tabulation, we have found that in the first column, there are two sign changes. Sign change number 1, sign change number 2. Positive to negative is a change. Negative to positive is a change. Two sign changes. Therefore, number of right-hand roots of that polynomial is equal to 2. To find the roots on the imaginary axis, this is special case problem, entire row becoming 0. So therefore, below the auxiliary equation, this x power 4 is the row of auxiliary equation. Below the auxiliary equation, we got to see the sign changes. Below the auxiliary equation, there is one sign change, implies one right-hand roots of the auxiliary equation, therefore one left-hand. Auxiliary equation roots are always symmetrical. One right-hand, one left-hand. It is fourth order auxiliary equation. When you say one right-hand, one left-hand definitely. And remaining two lies on the imaginary axis. Therefore, roots on the imaginary axis are 2. Definitely that auxiliary equation, if you solve, you are going to get those 4 roots. But not necessary to solve. We can easily say below the auxiliary equation, one sign change, one right, one left, remaining 2 imaginary axis. Therefore, roots on the imaginary axis 2. And remaining left-hand roots will be 3. total the 6 it has to match because it is 6th order, 6 roots are present. Therefore, number of left hand roots are 2. And those auxiliary equation roots are nothing but, okay, this characteristic equation or this polynomial roots only, this x power 6, those are 4 roots. They are within this x power 6 means within the 6 roots only. They are not different roots. Therefore, number of right hand 2, low omega x is 2 and left hand is equal to 2 roots. Friends, this is the second order system. Second order system, if you draw the Nyquist plot is like this. Omega 0 to infinity portion of the Nyquist plot is this. And the Nyquist plot is not intersecting the negative real axis. Whenever the Nyquist plot is not intersecting the negative real axis, gain margin will be infinity. Point of intersection of the Nyquist plot with respect to negative real axis, it doesn't exist. Whenever that is not existing, the gain margin of the system is infinite. If you calculate using the formula, we get omega pc is equal to infinity, we get it. Whenever omega pc is infinity 0, better drawing the Nyquist plot. From the Nyquist plot, we can say that the gain margin is infinity. It is a second order system. Second order system gain margin will be infinity only. Friends, Bode plot is given and the steady state error to a ramp input is asked of 10 units. 10 TUT means ramp of 10 units. Steady state error is equal to amplitude of the ramp divided by velocity error coefficient. So we need to know the transfer function GSHS. Here, it is a type 1 system. Initial slope minus 20 dB, therefore K by S into corner frequency 5 radians per second. Therefore, K by S into 1 plus S by 5 is the transfer function. Fine. What is the velocity error coefficient Kp? Limit S tends to 0, S into K by S into 1 plus S by 5. That is K. Velocity error coefficient for type 1 system is Bode gain K. That K is, you look at this given plot, K by S magnitude is 0 dB. K by S magnitude is 0 dB. One can see K by S magnitude is 0 dB. 0 dB means unity. K by S magnitude is K by omega. That is 0 dB means unity. So that is 0 dB. 0 dB means unity. So this is at omega is equal to 10. The same line is extended. The magnitude becomes, this initial characteristics are using K by S. K by S line is extended. Therefore, K by S magnitude is unity at omega is equal to 10. Therefore, K becomes K by S is equal to, K by omega is equal to 1. K is equal to omega, omega is equal to 10. Therefore, K is equal to KV is equal to 10. Velocity or coefficient KV is equal to Bode gain K. Bode gain K is equal to omega, which is 10. Therefore, K is equal to KV is equal to 10. Therefore, error is equal to 10 by 10, which is unity. 1, directly 0 dB it is intersecting at 10, KV is equal to 10. KV is equal to 10. Therefore, 10 by 10 answer. Answer is unity. Pen, paper not required. Friends, range of k for stability is asked. Loop transfer function is given k by s into s plus p into s plus q. Both p and q are positive. In fact, we do not need that Nyquist plot to solve this. It is simple using the RH tabulation. When you calculate, when you find the characteristic equation of this system, it is SQ plus P plus QS square plus PQ S plus K. Using the RH tabulation, we can easily find. This is the RH tabulation, and all the first column elements must be positive. There must not be any sign changes for stability. This is positive, this is positive. Therefore, S power 1 coefficient also should be positive. That means PQ minus K should divided by P plus Q should be greater than 0. Positive. Greater than 0 means positive. That is, from this we get K less than P plus Q into PQ. This is one condition, we get it. From the last one, K greater than 0, we get it. Therefore, range of K for stability is 0 less than K less than PQ into P plus Q is the answer. So we don't need that plot. When the transfer function GSHS is given, characteristic equation can be formed. RH tabulation, from RH tabulation, range of K for stability can be found. Nyquist plot of loop transfer function GSHS which has no right hand pole is given below. No right hand pole means in the formula P is equal to 0. N is equal to P minus Z, P is equal to 0. This is given data. No right hand poles, P is equal to 0 is given. This is a type 2 system because it is starting at near minus 180 degrees. It is type 2 system. Drawing the remaining, this is omega 0 to infinity is given, and the remaining sections are like this. Continuous path, this is omega minus infinity to 0, and you get two semicircles of radius infinite. This is one semicircle and this is one semicircle, and the center of this is at the origin, r tends to infinity. From the plot we have to calculate minus 1, this is 0 minus 10.64 means minus 1 is inside. This minus 1 encircles twice. This is 1, twice here, clockwise. This is also clockwise. Continuous path like this, mirror image, infinite radius. This is complete Nyquist plot. So therefore from the plot, N is equal to minus 2. Number of encirclements of minus 1 J0 critical point is equal to minus 2. Z is equal to P minus N. Number of right hand pole 0. Z is equal to 2. Z is equal to 2 means two closed loop poles are present in the right half of S-plane. This Z is number of right half of S-plane closed loop poles. P is number of right half of S-plane open loop poles. Encirclements of minus 1 J0 critical point by the Nyquist plot. Therefore, system is unstable with two right hand poles. Closed loop poles, these are number of right half of S-plane closed loop poles. Right half of S-plane closed loop poles. 2 poles. Hence answer is 2. Given data is loop transfer function is given. Asymptotes, where are they going to meet is asked. Asymptotes meeting point is nothing but centroid actually. Centroid is asked. Centroid is intersection of asymptotes. So it has three asymptotes. It has three asymptotes. All these asymptotes will meet at the centroid. Sum of poles, pole is 0, pole is -1, sum of poles, pole is -3, minus zeros, no zeros, divided by number of poles minus number of zeros, which is -4/3. Therefore, asymptotes will meet at the point -4/3, which is -1.33. Centroid is intersection of asymptotes, which is -1.33. Two systems forward path transfer function is given. System A, system B, both are unity feedback. System A characteristic equation is S square plus S plus 9. Comparing with the standard second order system characteristic equation, which is S square plus 2 zeta omega ns plus omega n square is equal to 0, we get zeta for the first system is 1/6. Second system zeta, similarly, if you compare omega n4, 2 zeta omega n2, you will get 1/4 is zeta. And system overshoot depends only on zeta. System 1 zeta is 1/6, system 2 zeta is 1/4. Therefore, system 2 has more zeta, MP is less. System 1 has less zeta, MP is more. Therefore, system 1 will be having more overshoot than system 2. Similarly, if you look at the settling time, 2% band settling time, or you can even take 3% settling time, 5% settling time, doesn't matter. Zeta omega n is 1/2 by comparing to the 2 zeta omega n is equal to 1. Zeta omega n is equal to 1/2. Therefore, settling time for the system 1, 8 seconds you will get it. System 2 settling time you will get 4 seconds. So system 1 settling time is more than system 2 settling time. Both overshoot and settling time of the system 1 is more than system 2. Given data is differential equation of the system is given. Definitely this Y is response. Left hand side is the output, right hand side is the input. This is the input, excitation or source to the system, input to the system, excitation. So here we have to find what is the ramp component in the output. How much is the ramp component that is present in the output? Therefore, by taking the Laplace transformation, setting the initial conditions to 0, S into Ys plus 2y of s is equal to 4/s square. Y of s is equal to 4/s square, this s plus 2 we will get it. That means C1/s square plus C2/s plus C3/s plus 2. This is the ramp component, because C1/s square inverse Laplace transformation is C1t ut. Therefore, this is the ramp component. Hence, we have found C1 is equal to 2. Therefore, ramp component that is present in the response is equal to 2 units. Look at that. C1 is 4/s plus 2 at s is equal to 0. Heavy side rule 2. Therefore, 2/s square. We are not bothered to find C2 and C3 because they are not the ramp components. Ramp component is only this. Therefore, taking the inverse Laplace transformation of the output, we get the response, this one. Hence, this is the ramp component. 2 units ramp is presented, the output ramp component in the output is 2 units. So 2t ut is the ramp present in the response.